Hi everyone, today we will be looking at the molecular orbital theory for N2 negative and N2 plus. Before we start, I want to explain the diagram we are looking at. So here, and here as well, will be your atomic orbitals for nitrogen. This two combined will be N2. So it would be your 1s, 2s, and so forth. This here in the middle will be your molecular orbital. So the purpose for the molecular orbital is to see if N2 negative and N2 plus exists or does not exist. Because this is a large 2s 2px interaction, our pi bonds will be low in energy. As you can see, we have a pi 2px and a pi star 2px. So the star represents the anti-bonding orbitals, so these are your anti-bonding orbitals. And the one without the stars will be your bonding orbitals. So these will be your bonding orbitals. For N2 negative, we need to add an electron to the 2p atomic orbital because of the negative charge. Now we can start filling up our molecular orbital. We have a total of 4 electrons here. So 2, 4. So we need to put 4 electrons in the molecular orbital. So 1 from the left, 1, and 1 from the right, 2, 3, and 4. We will do the same thing for the rest. So 1 from the left, 1 from the right, left, and right. For this orbital, molecular orbital, we need to fill up the lower energy first, which is our pi's. So we have a total of 7 electrons. So 1, 2, 3, 4, 5, 6, 7. Moving on to N2 positive, I've already filled out the 1s and 2s orbital and the molecular orbital. So what we should do now is lose an electron because of the positive charge, and we're just going to fill up the molecular orbital just like we did in the previous example. Now we have a total of 1, 2, 3, 4, 5 electrons. So 1, 2, 3, 4, 5. The ones in blue are bonding and the ones in green are anti-bonding. For N2 negative, we have 10 bonding and 5 anti-bonding. For N2 plus, we have 9 bonding and 4 anti-bonding. Now that we've figured out the number of electrons in the bonding and anti-bonding orbitals, we can finally find the bond order for both of them. We have 10 bonding and 5 anti-bonding, which makes it 2.5. We have 9 bonding and 4 anti-bonding, which also makes it 2.5. The species do exist. Since the bond order for both of them are the same, 2.5, we have to compare it to N2's bond order, which is 3. So the bond length for both is longer than N2. Low bond order means long bond length. The bond strength for both is weaker than N2. Low bond order means weak in bond strength, and the magnetic properties for both is paramagnetic.